Welcome everybody to today's webinar from the ILAE. Today we're going to be discussing potential impacts of climate change on people with epilepsy. This is a really live issue. Climate change is happening around us now. The impacts are more obvious in some places than others, but they are affecting us all in one way or another. We've heard today how scientists have estimated that the rise in temperature across the globe by the end of the century may be 2.5 degrees C, well in excess of what's considered to be safe. And we'll hear more about that today. I'd really like to thank the ILAE for arranging this and for supporting the work of the Climate Change Commission, and particularly to thank Professor Janet Mifsud, who put this all together, but unfortunately is unable to be with us today due to other commitments. We do have two fantastic speakers. Firstly, we have Dr. Stephen Blenkinsop, who's a senior lecturer in climate change at the University of Newcastle. I've had the pleasure of working with Stephen for some years now, and it's been really important to have Stephen's input as a climate scientist into the work that we've been doing. He's been able to keep us on the straight and narrow and to educate us about climate change. And we'll be hearing from Stephen about the state of climate change at the moment in the first part of the webinar. After that, we're also very fortunate to have speaking Professor Gagandeep Singh. I've known Gagandeep since before both of us had grey hair. Gagandeep worked many years at the Institute of Neurology, from where I'm speaking to you today, and is Professor of Neurology at Dayanand Medical College in Ludhiana in India, where some of the impacts of climate change are really already being felt on a daily basis. So I look forward to a really informative and important webinar, and I hope that it will persuade people to take action and engage with these issues, and please do get in touch with the Climate Change Commission if you would like to do that. Questions and answers will be taken at the end of the session and will be chaired by my colleague on the Climate Change Commission, Professor David Henschel from the RCSI in Ireland. So I'm very pleased now to hand over to Dr. Stephen Blenkinsop to give us an update on where we stand with climate change. Stephen, thank you.
Thank you, Sanjay, and thanks for inviting me along to speak. I'm really always pleased to engage with the ILAE, as you've said, for a number of years now. So it's something I'm really pleased and always happy to do. So I'm just going to start my presentation. Cool. I just want to start off saying I have no conflict of interest to declare. So yeah, where are we with climate change, this sort of state of the art? And you'll all be familiar with the Paris Agreement, which says that we've got a global target of limiting temperature rise to well below 2 degrees above pre-industrial levels, and pursue efforts to limit that warming to 1.5 degrees. Of course, we've seen year on year these temperature increases, which you can see in the graph there. And if I just highlight the figure at the end, we can see in the last year was the first year where the global temperature has actually exceeded that 1.5 degree threshold. That doesn't mean in itself that we've not met the target. It's just one individual year, and the 1.5 degree threshold relates to average climate exceeding that and average temperatures, but it's an indication of where we're heading and the direction of travel. And as Sanjay alluded to there, we've seen the announcement today of the track that we're on. 2003 has been quoted as being the year that confounded climate scientists to a great deal, and there was a total of 2.3 billion people, that's about 29% of the population of the Earth, experienced a world record breaking average temperature during 2023. So it's starting to have real reach in terms of the number of people affected, and CO2 levels in the atmosphere continue to rise. We recorded last year 419 parts per million. Last year was partly fueled by El Nino, which you might have heard of, which is this Pacific Ocean phenomenon that releases huge amounts of heat into the atmosphere. So that's kind of turbocharged that, and we might see that continue this year as well. So it all chimes really with what we're seeing and what the IPCC says, the Intergovernmental Panel on Climate Change, which says it's one of its headline statements from its last big report, which is that it's unequivocal that human influence has warmed the atmosphere, ocean, and land since pre-industrial times. That's, that word unequivocal is really strong there. And over successive reports, that the evidence that underpins that has been strengthened, and they've become more certain in that sort of statement. And we're seeing the signal of climate change in extreme rainfall, and which is manifesting in terms of floods, retreat of sea ice, melting of glaciers. So this signal that we're seeing from the climate is becoming very, very consistent. Just in terms of 2003, I did some little look on the World Weather Attribution Service, and this is a service where they run these studies using climate models when we have a major impactful event, and they can use the models to assess the extent to which climate change has contributed to that. Because obviously we would naturally get extreme events and they can have an impact just through natural variability of the climate, but we can use climate models to try and pick those causes apart. And during 2023, they actually looked at a number of heatwave events. So you can see there where they occurred. There was 2, 4, 6, 7 that they actually looked at. Effects were much more widespread, but these are the 7 events that they looked at. And all of those that were found with either the likelihood of that event occurring or the intensity of that event could be attributed to human-induced climate warming. They actually do this for other events, and it's a bit more difficult when you get to things like extreme rainfall. So you can see there, they looked at 5 events. 3 of those open circles you can see there, 2 in Africa and 1 in New Zealand. Again, they found a discernible human influence that had contributed to that event, either made it more likely or more intense. But rainfall is naturally more variable, so there's a bit more ambiguity. We can see 1 in Europe there where they couldn't find an influence, and another in Africa where there was just no clear result. And this is consistent. Again, we can do similar analyses, and we found drought events in 2023 that had significant impacts were attributable to climate change. And 1 look at a wildfire in North America as well, and they found that that was more likely to have occurred as a consequence of climate change. So we're actually getting to the stage where we can actually directly link some of these really impactful events with climate change. Just wanted to bring it down locally to health and what we're thinking about, and many on this call will be familiar with some of this. There are a number of sort of pathways to this impact from this change in climate. So you can see some of them there in the centre, through extreme weather events that we've been talking about, through heat stress, sort of interacting with air quality and water quality, and as we'll sort of hear later, in distribution of disease through various vectors. But that's also, the overall risk is actually shaped by other factors. So it can be population factors, socio-economic conditions, the kind of socio-political context. And I'm going to talk a little bit later as well about the health and capacity and resilience of healthcare systems, which actually shape our ability to address some of these issues. So we'll talk about that a little towards the end of this talk. So what are the recent trends that we've seen in relation to climate change and health? Well, they've sourced these from the IPCC report. And you see some headlines there: climate-related illnesses and premature deaths, threats to mental health and well-being are increasing. With very high confidence in that statement. And again, climate hazards are actually increasingly contributing to these adverse health outcomes, as I've just kind of talked about with the attribution studies. And overall, these net impacts are largely negative. There are some positive impacts of climate change, but overall, it's negative. In terms of what might happen in the future, we can use climate models, input our scenarios of future greenhouse gases, and do some modelling from that to see what the health impacts will be. And we can see that that does point to an increase in ill health and premature deaths from many of these conditions and diseases. And this is likely to increase under lots of scenarios of climate change. So it really is something that we need to talk about. I'll talk about some of the things we can do to actually meet that. And you can just see on the figure on the right up there, this is kind of a measure of the number of people days where people are exposed to heatwave conditions over recent decades, and the top 5 countries there. And you can actually see it's going to be driven partly by the increases in temperature that we've seen, but also by sort of a growing population in many of these places, and also an increasingly vulnerable aging population. So what we talk about, the overall risk rather than just the hazard of the heatwave, the risk is actually growing due to other factors as well. So I did mention attribution studies and how we link some of these impacts of climate change to actually human-induced forcing. And there's some of these have actually been done now for health. The first one of these was looking at the impact of the 2003 heat wave that affected Europe. And again, this is using computer simulations to do this and to analyze them. And you can actually found that the increase of heat-related deaths in Paris during 2003 was 70% higher as a consequence of climate change. So if we hadn't emitted those greenhouse gases, there would have been fewer deaths. So there's been relatively few of these attribution studies. Some of them, ones found that all regions that they looked at across the globe currently experience at least 10 additional days per year when thermal deaths, that's deaths due to extreme heat, are expected to occur. There was another big study looking at 43 countries and found that a significant proportion of warm season heat deaths can be attributed to human warming. How they actually do this, they look at these climate model simulations and they look at simulations with greenhouse gases and alternative simulations without greenhouse gases. And you see the difference in that figure there of the temperature that you get when you don't have that driver in there. And we can actually use sort of observed relationships between temperature and health outcome in different countries. And you can see there the risk of mortality, a risk measure that they've constructed for different temperatures for Germany. So they can then take those future simulations and those sort of different scenarios and apply that observed relationship. And we can see here that the proportion of heat-related mortality due to climate change is actually detectable in many of these regions. And that's kind of had a further impact. You might have seen very recently in Switzerland, there was a group of, I think it was largely women, who took the Swiss government to court over its climate policies. And they argued successfully in the European courts that their health and livelihood and life was being adversely affected by climate change. So we're seeing increasingly these studies inform litigation for the effect it's having on people's lives. So I just wanted to sort of finish off by talking about sort of what we can do. And here we can see, obviously, the main thing we need to do is reduce our emissions. So we have a thermometer on the left-hand side there. We can see our goal of 1.5 degrees. And you can see the "we are here" sign saying we're around about 1.3, 1.2, depending on which measure you look at of warming. And those different bars show us where different sort of current policies will take us. So our current policies will take us to 2.7 degrees of warming. So we've got a gap there in terms of our emissions and what we need to do. If we look at where we've got pledges and targets, we can see that comes down, but the policies aren't yet in place to sort of reach those targets yet. So that 2.7 one is kind of where we're at in terms of what is actually on the books to be implemented. So we can see we've got a big gap to close there. And just in relation to the health sector, you can see health sector is part of that. It contributes 4 to 5% of the emissions of greenhouse gases worldwide. So there is a role to play, and the ILAE has been really proactive in seeking to how it addresses its emissions. And we can see there that's not just in terms of the energy that the hospitals use, but across the whole supply chain. And it's thinking about how, as a sector, the health sector can reduce those emissions. And just in terms of, you might have heard of net zero, and it's just important. I just put this graph up because it's important to think about how we get there and when we get there. So this is just a simple cartoon graphic showing our emissions with time. And at the right-hand side, we've got to net zero. If you look at that black line where we delay action and get to net zero closer to 2050 and compare it with the blue line where we sort of take action now, we get to net zero, but there's actually that shaded area represents additional emissions by not taking action now. So, delay isn't an option. If we delay, we might get to net zero, but there's a lot more emissions will accumulate in the atmosphere. The other thing we need to do is think about adaptation, think about the risks. So thinking about some of those health impacts and what we can do to reduce those risks and vulnerability. So here's just an example I found just relating to particular groups, and obviously people with epilepsy are a particular group that we're concerned about here, and particularly the impact on heat. We can see some of the groups there and some of the adaptations that can be taken place. So things like disaster management plans, changing people's behaviours so they're not exposing themselves to some of these hazards, but also adapting our cities so that they keep cool, for example, or are flood resilient, depending on what the hazard is. And here's just an example of that. This is a brand new hospital that was built in Singapore to try and accommodate climate change and adapt to it. So it was oriented to maximize daylight and natural wind flow. There's shading there to reduce solar gain in the building. And you can see a green roof and garden there, which helps to cool as well as absorb water if there's intense rainfall. And it's really also adaptation. It's all about addressing some of the wider issues. So think about this globally. So addressing some of the broader issues about education, allowing people to address the challenges themselves, equipping them to be able to understand the risks and to be able to make decisions for themselves. But also about addressing inequality and hunger, because these increase the vulnerability and exposure to these hazards. So it's not just about buildings and adapting sort of physical infrastructure. It's about sort of people's context as well. But again, as we have an adaptation gap, we also have as we have an emissions gap, we also have an adaptation gap. And you can see here, one of 6 countries don't have a national adaptation plan. There's limited evidence in the UK of adaptation at the scale needed to fully prepare for climate risks, and particularly in relation to health. The Climate Change Commission that did this research found that there are limited policies and plans to protect the population health from the impacts of climate change and to deliver healthcare. So we have another gap there between what we know we need to do and what we're actually doing. And I think this is just the final slide before my conclusions. I was thinking, what are the gaps? And there's another gap, of course, in terms of the evidence and the science. And I just did, this wasn't a rigorous literature search, but I just went into Scopus search engine and had the search term climate change and then different health hazards, and just to see what literature came up. And you can see the large numbers there for things relating to climate change and heat stress, vector-borne diseases, malaria, dengue fever, and mental health. But in terms of climate change and neurology and epilepsy, it's much fewer, and many of those are kind of not the sort of fundamental research, but are sort of contextual and setting out the problem. So there's a gap there in terms of the research. So this is just my concluding slide, really. Just wanted to sort of emphasize that, it is evident, it's unequivocal, as the IPCC say, that anthropogenic change is happening, and it's having an effect on human health. And that this is going to increase. The projections from the models show that extreme weather will increase, and it's consistent with our evidence. But we're also seeing increasing vulnerability with aging populations and other problems as well, demographic problems. So the call to action is really that we know what we need to do, but we need to bridge these gaps. We need to bridge the gap on mitigation, on emissions, and everyone here has a role to play in that. But we also need to bridge the gap on adaptation, thinking about how we can adapt our communities, but also our workspaces, so that they aren't exposed to these hazards. And also think, how do we address these evidence gaps in the fundamental science? What are the links between climate and neurological conditions and epilepsy? And so just to finish off, so you were important. It's not just climate scientists that can do this. I can provide the evidence, I can provide the fundamental information on how the climate is changing, but climate scientists, aren't experts in health and those kind of important interactions that takes place. And this is where it is a community. It's everyone needs to get together and solve this, and everyone has a role to play. So as it says there, you are important, even though you might not see yourself as a climate specialist. You're just as important as people that work directly in that climate community. So I think I'll stop there and hand over, I think, to the next speaker.
Thank you very much, Stephen. It's a really clear presentation of where we stand at the moment and the huge gaps that need to be filled. And I think it's a really important point you make, that everyone has a role to play. So we're going to hear a little bit now more specifically about risks in epilepsy and for people with epilepsy from Professor Gagandeep Singh. Over to you.
Right. My slides visible?
Yes.
Right. Thank you so much, Sanjay, and thank you, the Climate Change Commission, for asking me and inviting me to speak on this topic. I don't have any conflict of interest, not certainly with the topic that is in discussion. I just want to add a disclaimer. I mean, before Sanjay and colleagues invited me to ask me to speak on this topic. It was very little that actually I knew about this topic, and therefore it's been really instructional for me. It's like a great scholastic opportunity, and I'm indeed grateful because it was challenging. Certainly, there was no doubt that a new topic, which is completely away from epilepsy and neurology, something that I have been doing for the last more than 30 years. But I think it's really relevant, and I really would like to congratulate all the members of the Climate Change Commission of the International League Against Epilepsy for having taken up this important issue. And I think they're going to really end up with some very useful information, some very useful recommendations, and something to develop. So when I started, I looked across went across a few climate change websites and different countries. This is something that I understood that, and I think we all experienced this. 2003 was one of the warmest years in the last many, many years. And this is something I quote from this particular website that, temperatures change and climate always evolves, and there is this huge variation within years and across the years. But the observation that it's been really 45 years since we have had a colder than average year is a little alarming. Nevertheless, this makes more sense to me as compared to this particular thermograph, and I can make out of it. This is the change in climate or the change in surface temperature. You can see that the brunt has been borne by the North Pole, the northernmost regions, but then almost all countries across the world, across the 6 continents, leaving aside very few areas, being really largely affected by this temperature change. In terms of diseases, and specifically in terms of infectious diseases, I think there are probably the list is longer, but this is what I could gather, and this is the list of various infectious diseases that have been found susceptible to climate change. For some of them, there is a huge volume of work which is now available and is worth reviewing, but for the others, there's probably a huge gap. That evidence gap needs to be fulfilled. Many of these infectious diseases are vector-borne diseases. So they're actually transmitted by vectors, for instance, insects or whatever, animals. And some examples of these are dengue, West Nile fever, Zika, malaria, Lyme's disease, and so on and so forth. And many of them have been associated with epilepsy, and dengue encephalitis causes acute seizures. There is no doubt about that. It can affect the brain, condition known as dengue encephalitis. And many of these affected people have acute seizures. Although the association with epilepsy as a sequelae of dengue is yet not forthcoming. Powassan encephalitis is a tick-borne encephalitis, and again is a rare condition, but is an important cause for epilepsy. Likewise, West Nile virus encephalitis. Zika, although it's a relatively new entrant, but we know that it is associated with neurodevelopmental delay in affected babies, as well as epilepsy that can be very difficult to control in the early years of life. The association with epilepsy is probably strongest and has been best shown across a number of epidemiological as well as facility-based studies for malaria. So these are some of the conditions or the infectious disorders which have been associated with epilepsy. And going on to the global distribution of some of these infections. And so if you look at malaria, the first map, malaria is basically concentrated currently in most of the sub-Saharan Africa. And there are pockets within South America, Central America, South and Southeast Asia. Just imagine, and then for dengue, for dengue, you have much of sub-Saharan Africa, South and Southeast Asian countries, that's the huge hub, and then Central and South America. But just imagine if this particular map or distribution in these maps were to reverse or were to extend from across many different continents, far beyond what is depicted as the main zones for endemicity for these particular infections. Likewise for West Nile virus, and these are some of the regions within the United States. This is data from the CDC, which are where there are human cases as well as animal cases. In terms of vector-borne diseases, particularly vector-borne diseases which affect the human brain and therefore can lead on to epilepsy, it's basically a link or a triad between the microbial organism or the pathogen. There's the vector, often mosquito, but then there are different vectors. Many of these infections have host reservoirs which are different from humans. For instance, horses and birds in West Nile virus encephalitis. But the thing that really links all three is the environment. And then today, we are going to spend some time thinking about and talking about the environment. You have different mosquitoes and different infectious agents. For instance, the Aedes has been associated with dengue, yellow fever, chikungunya, the Culex with West Nile virus, and the Anopheles mosquito with malaria. This is the life cycle of malaria. And you see, there is no host reservoir other than humans, but you see, when the mosquito bites, it injects the agent, which is plasmodium, known as plasmodium, and there are at least 4 species of plasmodium which can lead on to malaria. 2 of them are well known. I'll talk about them a little later. And then there is a cycle in the human blood and the liver, and from there onwards through the blood, the parasite can go and lodge into different organs. And then there is this life cycle which is perpetuated in the mosquito. When the mosquito bites again, takes a blood meal, and the gametocytes of various plasmodium species are gain access into the bloodstream of the mosquito and develop into mature parasites there. So it's Plasmodium vivax, which causes the usual malaria, which is very uncomplicated. There is fever, which might vary from days to weeks, often with chills and rigors. There's the complicated malaria, which is a problem. It usually occurs with Plasmodium falciparum, but can sometimes also occur with Plasmodium vivax. And by complication, we mean there could be anemia, organ dysfunction, and a variety of organs from the liver, kidney, brain. And perhaps the most serious form is cerebral malaria, when the brain is affected. It's basically because the parasite, once it invades the red blood cells, this leads to sequestration of the red blood cells. And it is the sequestration of the red blood cells and associated dysfunction of the vessel walls in the various organs, including the brain, that leads on to the acute symptoms of falciparum malaria. When we have cerebral malaria, these patients usually present with varied degrees of altered sensorium. They can have acute seizures and then focal neurological deficits. Acute seizures are particularly common. Most of the affected people with Plasmodium falciparum malaria are children from 0 to 5 age group. The other major group is pregnant women. And because it is in the 0 to 5 years age group, and these children often have seizures, so the question is, are these febrile seizures? But malaria-associated seizures are slightly different from simple febrile seizures. They might, of course, be very prolonged, and they're frequently asymmetric and focal in presentation. There are indeed a lot of long-term sequelae besides the acute infection. Acute infection is associated with a huge mortality, 10 to 20%, I think. And those who survive are often left with several long-term sequelae, including neurodevelopmental disorders, epilepsy, and focal neurological deficits. Some statistics. The last 20 years has indeed seen a decline in the incidence of malaria, which is very heartening, at least till 2019. Then the COVID came in, and so that was a little bit of a bump there. But still, we have 249 million cases of malaria every year across 85 countries. This has gone up slightly. This is 2023 data, 22 data, and this is slightly up in comparison to 2021. And there were 4 countries which reported an increase in the incidence of malaria in 2022, and one of them was Pakistan, and that's an interesting story from the climate change perspective, and I'll talk about that a little later. And of course, in Ethiopia, and I'm going to talk about Ethiopia also in the subsequent slides. And this is also a very interesting story. Most of these cases, 94 to 95%, are from the sub-Saharan Africa. There are nearly more than 500,000 deaths, of which 95% are from Africa. And then malaria during pregnancy is a big issue. So the 0 to 5 year age group, children, and pregnant women. That's the they are the ones who are most affected by malaria and cerebral malaria. Yeah, so we come to the association with epilepsy, and there have been a number of studies, and there are in fact a number of systematic reviews and meta-analysis, and this is one of the recent ones. And this took up 17 cross-sectional and cohort community-based studies. And the pooled odds ratio, as you can see here, for an association with epilepsy was 2.36. And when we look at cerebral malaria, the odds ratio actually went up to 7.10. And those are the confidence intervals. So having cerebral malaria, and the odds are pretty high in children as well as in adults, but also in children. So from malaria, which is the prototype infection, and I'm going to be focusing mostly on malaria. Let me try to talk a little bit of weather. I'm sure I'll not be as convincing as Stephen. He's the expert, but I did try to understand this, and it's the El Nino effect, which I do remember reading in school, but then I completely forgot about it. But this is very interesting phenomenon. This interesting phenomenon occurs across, the epicenter, I believe, is in the Pacific Ocean, between the Americas, the South America and the North America, and you have Asia and Australia. towards the west. And basically what happens is there are trade winds which travel across the tropical part of the Pacific Ocean and the equator from across America towards Australia and Asia. And what these winds do is they carry the surface water, which is warmer as compared to the water which is deep inside the sea along with them. And therefore, temperatures are higher towards Australia and Asia. This causes convection, evaporation of water, and then finally rainfall. So often there can be a lot of rainfall in Australia and Eastern Asia. And what happens in the Americas is because the surface warm water has shifted towards Australia and Asia, the cold water rises up in the American West Coast, in the South American West Coast. And this is known as upwelling. This is very good, by the way, for the fishes. But then this has tremendous implications in terms of the weather. Usually, this whole shift of temperature is probably less than 0.5. It's pretty unpredictable. It can happen once in 3, 4, 5 years. There's no fixed time. Stephen mentioned that we are currently going through the El Nino. But basically what it does is it leads to a number of unexpected weather events, right? And many of them can be quite catastrophic. So there could be excessive rainfall in one sector, for instance, in Australia and Asia, or there might be drought there, and there could be excessive rainfall or drought in the South American region. So this is the El Nino and the La Nino, El Nino and the La Nino effects, and this has profound effect on different weather events. And the effect is not just restricted to Australia, Asia, America. It can actually be felt as far as India. And there are certain states in India which are really affected by the El Nino. There are places in the East African coast, particularly Ethiopia, Kenya, and so on and so forth, which are often where rainfall is profoundly affected by the El Nino. So, right, let me get this through. Right, yeah. Right, okay. Right, so we come to Ethiopia, and right, yeah. So you see, Ethiopia has a unique location within Africa. It's very close to the Horn of the Africa, and which is why it could have quite varied seasons and different types of rainfalls in different parts of the year. So in the north and the northwest, it seems that the main rainy season is between June and September, whilst in the rest of Ethiopia, which is mainly the south and the east, it is more like rest of the Eastern Africa, and the rainy season is, I've never been to Ethiopia, so I don't really know, but it seems that the rainy season in this part of Ethiopia is mainly from October to December. The other characteristic of Ethiopia is that it has a lot of highlands, and the highlands might, as I read, might be as high as 2,500 meters. That's a substantial temperature drop from the plains, and this makes the climate of Ethiopia really, really very interesting from a climatology perspective. And this has important implications when we talk about the phenomena such as El Nino and La Nina occurring. And you can see that during the El Nino period, you can have a dramatic and a paradoxical change in weather in either the northern region or the southern region. This is basically what has been depicted in this particular map taken from this paper published in the Malarial Journal. Indeed, temperature has a profound effect on the incidence of malaria through a variety of different ways. And I will talk about that a little later. But Ethiopia is one of the ideal countries because of the weather changes, the rainfall seasons, and the highlands, and the presence of highlands. And therefore, the incidence of malaria has been studied extensively in this country. And a clear association between temperature and the incidence of malaria with a slight lag. So there is a lagged association. What a lagged association means is that there is indeed an association, but the malaria incidence lags the occurrence of the rainy season by about 1 or 2 months. And this is very interesting and presents a very good opportunity for intervention. So you have rainfall and you know that the malaria is going to follow in the next couple of months. So this presents an opportunity for intervention for all kinds of preventative efforts. And then likewise, the incidence of malaria has also been studied in the highlands of Ethiopia. And as you would imagine, as one goes higher and higher in the highlands, above a certain height, the incidence of malaria actually goes down tremendously. So that is a very important thing. And the idea is that if there is a climate change, there is global warming, the temperatures in the highland are likely to rise. And are we likely to see more and more cases of malaria in the highlands? That is something that has been studied in the malarial highlands. So temperature has a profound effect on the incidence of malaria, and this is both through the impact of temperature on the vector, which is the mosquito, as well as the impact of temperature on the pathogen or the infecting organism. Besides temperature, there are other factors which promote malaria incidence in many countries in the tropical world, that is rainfall, humidity, and the presence of stagnant water in which mosquitoes often breed. There is the climate, and then there is also the political climate, which is extremely important and is rather, we have turbulent times, and therefore the extremely volatile political climate also compounds the effect of weather, temperature, rainfall, and so on and so forth on malaria incidence. This is this very interesting study, and I quote from the study where they looked at different models of the vector and the parasite, and found that there is a temperature which is optimum for transmission of malaria, which was 26 degrees, but there is a range between 17 degrees and 35 degrees. Beyond the confines of this range, malaria transmission actually decreases tremendously and hugely decreases. So that is something to note. And the factors that are really impacted by temperature include the longevity of the mosquito. Biting ranges also depend on temperature. Fecundity depends on temperature. The parasite development rate, extrinsic as well as intrinsic, are also dependent on temperature. So temperature influences and can impact the incidence of malaria by acting at many different sites within the life cycle of the plasmid. So how I interpret it is that the climate indeed changes. And this is data from studies mainly in Ethiopia, but also in some other countries. I think similar studies in Ecuador too, where people have looked at the effect of different seasons. Malaria is really a seasonal disease. And then the effect of height and temperature on the incidence of malaria. But the climate, I mean, if there is global warming, what I anticipate is that there is going to be an increased intensity of transmission in some of the endemic regions. We've seen what are the endemic regions across the world. Elimination has been successful in many countries, even in Africa. If the climate change continues unabated, we might think that malaria would be reintroduced to these areas and then also spread to many other non-endemic areas. Geographical limits are likely to spread considerably. So what happened in Pakistan in 2023, and this is from the BBC and many other, the WHO and so many other places, Pakistan experienced unprecedented floods like never before, really affected a huge population, almost the entire Pakistan, particularly the western central Pakistan, in these floods. And the reason for these floods was an unprecedented monsoon season. Huge monsoon showers, and this was probably precipitated by the climate change events that happened. But what happened was that there was an epidemic of malaria. Nearly 5 million cases of malaria across Pakistan. It's a huge number. That really contributed to the peak of malaria, global peak of malaria, surge in malaria in the 2022s. Many countries, particularly the developed countries, for instance, the last British malaria outbreak was during the Balkan War, in the Balkan battle in the First World War. And in that battle, I believe both the sides actually lost, and it was the malarial parasite that won. And so many people were affected. So many of the army men were affected by malaria. But that's the last probably the United Kingdom saw of malaria. But this report was really shocking. And in the year 2023, there were as many as 8 cases of malaria locally acquired in many different states in the United States. Right. And likewise for dengue, likewise for some of the other infections. So, ladies and gentlemen, I think the implications of climate change are much more beyond the health sector. We have to understand that this might lead to loss of livelihood, food insecurity, might lead to increased healthcare demands. Already in a situation where there is tremendous healthcare inequity, access to healthcare is extremely poor, and a huge amount of human displacement, animal displacement, and so forth. So the effects are likely to be tremendous. What do I think will be the actual picture? I mean, we need to understand that if there is so much of global warming, some of the preventative tools might also become ineffective. We need to make them heat resistant. Some of the diagnostic equipment and some of the medicines might not work as well in those high temperatures. So these are some of the implications of climate change. And all of this is likely to translate into increased cost. We have in the last year or so the World Malaria Report, and it's very heartening to note. Every year there is a malaria report, a global malaria report. the 2023 World Malaria Report has about 3 pages on climate change. So this is the kind of importance that was given to climate change and climatic aspects of malarial transmission. And this is the first time that the impact of climate change on malaria, the potential impact of climate change on malaria incidence has been acknowledged. And there are these other 2 documents, one by the WHO and other by the Lancet Commission, which have been published, which look at different scenarios with regard to malaria eradication. But I like this paper in the Malaria Journal 2021, which basically talks a lot about climate change and how we can make the entire malaria eradication climate proof, right? So that is something, and they discuss a variety of different scenarios depending on how much the climate change and how aggressive our eradication effects are likely to be. We have a fairly robust malaria eradication drive. In the 1950s, when the WHO was the early days for WHO, they went on a global malaria eradication program and they failed. They failed miserably that time, perhaps because they had not considered the intensity of malaria transmission in most of Africa. Is this climate change all a hype, or is it really a desperate situation? I think the eradication efforts need to be continued. There is no doubt about it. And I have no doubt that with proper implementation, the political will, as I quote from this particular, this is from the Global Malaria Report 2023, that malaria eradication should not be a campaign, it should be a policy. And this particular gentleman said so in not just recently, in 1939. I don't think we need to despair in terms. That's what my take is. We don't need to despair, but and it's not like the end of the world. But we need to keep climate change in mind. We need to continue and intensify our malaria eradication efforts or elimination efforts. But we really need to factor in climate change, and that would be very sensible. That would be a sensible thing to do. But more than that, what all these studies and all this huge volume of research in terms of the interaction between climate and malaria tells us is it can really offer us very good insights into how we should incorporate climate change mitigation measures in the malaria eradication drive, in our efforts to reduce the burden of epilepsy across the world, in our efforts to mitigate the long-term neurodevelopmental and other neurological consequences of malaria. Thank you so much.
Gagandeep, thank you so much for your presentation, and thank you also as well to Steve Blenkinsop for his presentation before that. That was a really terrific overview and introduction to the challenge of vector-borne diseases, particularly around malaria, which of course is one of the major challenges. And I think you've nicely captured the complex interplay between what's happening in the environment, what climate change is driving, and how we as a society, and more specifically as an epilepsy community, will need to be prepared for this and to think about how to address it. I wondered if we were available for a couple of questions. I wondered if I could ask maybe a leading question for Gagandeep first. Are there areas of research that you would prioritize, based on the presentation you've given and your thinking on this topic? Are there areas of research that you would prioritize for the epilepsy community?
Thank you, David. Yes, I think we have learned a lot about in terms of the association between malaria and epilepsy in the last few years. Till many years, it was still in the dark because we didn't know what is the substrate responsible for epilepsy. That's something that we don't know for many other infectious disorders. For instance, onchocerciasis. We believe that there is an immune mechanism, but it's largely because MRI and CT scans are so scarce in most of Africa. So that understanding is important, and that's probably one of the first steps in our understanding of why epilepsy occurs in many of these infectious disorders. The impact of climate change, the impact of unexpected weather events, whether these are droughts or, droughts are also important. I wonder if I mentioned, droughts do not lead to malaria, but then rains after the droughts often lead to malaria. So understanding how this might eventually translate in terms of impact on long-term neurodevelopmental sequelae, epilepsy, and focal neurological deficits. So that is something that eventually needs to be understood. Although it's going to be really difficult because, it's the time scale involved, the huge scale of investigation involved. So it's going to be difficult. Logically, I think it makes sense to think about it that way, but that's something where we actually can contribute.
There's a question in the chat box here. Can climate change increase zoonotic diseases?
Right. So the typical example of zoonotic disease is schistosomiasis. I don't think climate change has really been, the impact of climate change on conditions like schistosomiasis has been investigated. It's thought more to be associated with hygiene problems and so on and so forth. But that's an interesting area for investigation. We really don't know. But these are the other zoonotic diseases like no, I don't think much has been done in terms of zoonotic disorders. It's mainly the vector-borne diseases, because there is a vector, there is an insect or an animal or a whatever vector which transmits, and therefore the environment can really influence the incidence of that particular disease.
And Gagandi, maybe I could ask a question just around treatment. Are there recommended standards or rather things like anti-seizure medicines? Is there anything known about their use in certain types of vector-borne or presumed vector-borne causes of epilepsy that work more or less effectively? Are there any guidelines on anything like that?
Well, in terms of studies, I don't think much has been done in what might be the ideal anti-seizure medication or in terms of duration. But generally, the guidelines and the recommendations for treatment of epilepsy in general apply to most of the infectious disorders. There are issues like drug interactions between many of the anti-infective agents and the anti-seizure medications. So we need to be mindful of them, these interactions. We need to be mindful of the cost and availability. So in much of Africa, if we prescribe something like perampanel, I think that would be a kind of really uncalled for thing. But yes, I think these are some of the issues.
We are getting close to time on the session. I don't know if there's anyone else, maybe a panel member, if there's any other questions. What I would ask anybody attending the session today is please complete the feedback form, which will be either presented or it's in the it's in the chat. We really welcome people's suggestions, both feedback on this particular topic, as well as any future topics that you might be interested to hear about in relation to climate change. So do send us your thoughts on that. If not, I will hand over back to Sanjay. I'd just like to again thank Gagandeep and Stephen and everybody for listening here, and the ILAE for providing the forum for today. Sanjay, back to you.
Thank you very much, David, and thank you again, Stephen and Gagandeep. Really important talks, sobering, I think I would say, and obviously a very serious topic. But I think another important message both of you gave is that there are opportunities for intervention and opportunities for action and opportunities for all of us to make a contribution and a difference. So thank you for showing us that. And thank you to the audience for joining. And as David has said, if you're interested, please just get in touch. There are lots of opportunities for things for us to do. And thank you to the ILAE for hosting this. Thank you, everyone. Bye-bye.